Alright, first one. GCF at the top. The GCF of 2 and 8 is 2. So you pull out a 2 and you get x minus 4. On the bottom, that says 4 minus x. They look similar, but they're not the same. So what I'm going to do is I'm going to factor a negative 1 out of the bottom. So when I do that, negative x divided by negative 1 is positive x, and 4 divided by negative 1 is negative 4. And since they're the same top and bottom, we cancel. And 2 divided by negative 1 is a negative 2. GCF is x. So you pull out an x, and you end up with x minus 5. In the denominator, two numbers that multiply to 10 and add to negative 7 would be x minus 5 and x minus 2. Those cancel. And so we're left with x over x minus 2. And it says state any excluded values. It means what numbers can you not plug into this function. So this says what number minus 2 equals 0. That means I cannot plug in x. X cannot equal positive 2. Factor, the GCF is 2. So 2 times x squared minus 16. All over, pull out an x because the GCF of all of that is an x. So x squared plus 6x plus 8. The top is difference of two squares. So that would be x plus 4x minus 4. And the denominator, two numbers that multiply to be 8 but add to 6 are 4 and 2. So x plus 4, x plus 2. So your final answer is 2 times x minus 4 all over x times x plus 2. And x cannot equal 0 because of that x that's in the front. And x cannot equal negative 2 because of the x plus 2. For this problem, we're going to factor by grouping. So factor, group those, group those. GCF of that would be x squared, and you would be left with an x plus 3. And the GCF of that, we could pull out a negative 1, and that leaves us x plus 3. And in the denominator, we could pull an x out of all of that, so x times 2x squared plus 5x minus 3. And in the numerator, they both have an x plus 3 in common, so I'm going to factor out x plus 3. And what I'm going to be left with is x squared in the first part of my parentheses and minus 1 in the next part of my parentheses. All over, oh, I forgot the x squared on the numerator, my mistake. All over x times all this stuff, 2x squared plus 5x minus 3. So we can factor the x squared minus 1, that's difference of two squares. So x squared times x plus 3 times x plus 1 times x minus 1. And in the numerator, or sorry, the denominator, I can factor this. I know my first two have to multiply to 2. And my last two numbers have to multiply to negative 3. So I need a 3 and a 1. And this will be a positive 3 and a negative 1. So this is just guess and checking. Again, my first two multiply to be 2x squared. My last two multiply to be negative 3. You'd have to check to make sure that they work out, and these work out. And then cancel what you can. The x plus 3's cancel. And this is x squared, and this is just an x. So you subtract the exponents. 2 minus 1 is 1, and it's going to end up on top. So this is going to be x times x plus 1 times x minus 1 all over x times 2x minus 1, where x cannot equal 0 because of that x in front. And we also can't have this equal to 0. So you would say 2x minus 1 cannot equal 0. 2x cannot equal 1. So x cannot equal 1/2. For number 5, kind of just reduce as you go. 3 and 12, they have a GCF of 3. So 3 goes into 3 once, 3 goes into 12 4 times. So 1 times 9 is 9, 4 times 4 is 16. And now we start getting rid of variables. This is x to the first power and x to the third power. So since this exponent's bigger, your final x is going to be in the denominator. And 3 minus 1 is 2, so that's going to leave you with x squared. And since there's more y's in the numerator than there are in the denominator, 2 minus 1 is 1, and it ends up in the numerator. And that's our final answer. When you divide by a fraction, you just flip and multiply. So we have 7x over 12yz squared times 18y squared z cubed over 49x cubed. So the GCF of 7 and 49 is 7. 7 goes into 7 once. 7 goes into 49 7 times. GCF of 12 and 18 is 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So in the numerator, 1 times 3 is 3. And 2 times 7 in the denominator is 14. Now we handle the variables. So let's do the x's first. There's a singular x right here, x to the third. Since the bigger one's in the bottom, your final x is going to be on the bottom, and 3 minus 1 is 2. 2 y's in the numerator, 1 y in the denominator. 2 minus 1 is 1. And 3 z's, 2 z's, 3 minus 2 is 1. And since the bigger one's on top, z goes up top. Final answer. For number 7, we got to factor everything. So two numbers that multiply to negative 10 but add to negative 3. That's x minus 5, x plus 2. This factors to be x minus 2, x minus 2. 4 out in front times x minus 2. We pull out the GCF. And the GCF of 2 and 10 is 2. So 2 times x minus 5. And we can start canceling a whole bunch of stuff. X minus 5's go away. X minus 2's go away. And 4 divided by 2 is just a 2. So our final answer is 2 times x plus 2 over x minus 2. Okay, I'm so zoomed in. My bad if I end up going off the paper. GCF of 2 and 18 is 2. Actually, let's flip and multiply first before I do any of that. 2x squared minus 18 over x squared minus x minus 2 times x squared plus x minus 6 all over 10x minus 30. So GCF the top left, that's 2 times x squared minus 9 all over x squared minus x minus 2 times x squared plus x minus 6. GCF of 10 and 30 is 10, so pull out a 10, you're left with x minus 3. And let's factor everything that we can. This would factor, this is difference of two squares, so that's an x plus 3, x minus 3. This, two numbers that multiply to negative 2 but add to negative 1 is x minus 2, x plus 1. Two numbers that multiply to negative 6 but add to 1. That would be an x plus 3, x minus 2. And that would just stay the same. And let's start canceling stuff. So x minus 3 will cancel. X minus 2 will cancel. And the 2 and the 10 can be reduced. 2 goes into 2 once, 2 goes into 10 5 times. So in the numerator, we have 1 times x plus 3 times x plus 3, which is just x plus 3 squared. And in the denominator, we have a 5 and an x plus 1. I'm going to start doing problems on a separate piece of paper now because I'm going to run out of room. Alright, number 9. Number 9 says 4 minus x squared over x plus 2 times 12x over 3x minus 6. First things first, I'm going to factor a negative 1 out of the top left so I can switch things around. So it becomes x squared minus 4 over x plus 2 times 12x. And I'm going to GCF this right now. 3 and 6 is 3. And you're left with x minus 2. And this is difference of two squares. So this is negative 1 times x plus 2, x minus 2 over x plus 2 times 12x over 3x minus 2. So the x minus 2's will cancel, the x plus 2's will cancel, and so we have 12x divided by, negative 1 times 12x is negative 12x divided by 3, which comes out to negative 4x. That was number 9. Number 10. Number 10, we have a frac and frac. So we got 3x squared plus 30x plus 75 all over x minus 5 divided by x over x squared minus 25. So I'm dividing by a fraction. So what I'm going to do is I'm going to take this bottom and I'm going to flip and multiply. So this becomes 3x squared plus 30x plus 75 over x minus 5 times x squared minus 25 all over x. And in the numerator, I can factor a 3 out at the very front. So I'm left with x squared plus 30, not 30, plus 10x plus 25 over x minus 5. And for this right here, this is difference of two squares. So this comes out to x plus 5, x minus 5 all over x. Factor the numerator right here. And two numbers that multiply to 25 but add to 10 are x plus 5 and x plus 5. Okay, and we get to start simplifying stuff. The x minus 5's will go away. So our final answer is 3. And there's x plus 5, x plus 5. There are 3 x plus 5s, so that's x plus 5 cubed all over x. Number 11. we have 3x plus 2 over 5x squared minus x times 10x squared plus 3x minus 1 all over 6x squared plus x minus 2. So let's start factoring stuff. Top left can't factor anymore. This guy, man, I really got to work on my 3s and 5s. Pull out an x, and you're left with 5x minus 1. The first two have to multiply to be 10. I'm going to do this method. So negative 1 times 10 is negative 10, positive 3. So that would be a 5 and a negative 2. So I know that my first one, this will be a 2x and a 5x. And the last numbers have to multiply to be a negative 1. So that is a 1 and a 1. And since the 3 is positive, that means this is positive, negative. And in the denominator, we have a 3x and a 2x, 2 and 1, and they must be a positive, so this would be a positive, negative. Is that right? Let's see. X plus 4 times x minus 3. Apologize by putting the 6 underneath it. Yep. Okay, you guys didn't see that. Totally didn't see that. Okay, but you guys can guess and check all you want. I just don't have the time or the patience to do that. So 3x plus 5 and a 3. Why did I put a 5 there? That was a 2. That was always a 2. Bringhetto, what are you doing? Okay, so now I can cancel stuff. The 3x plus 2 and the 3x plus 2 cancel. The 5x minus 1, 5x minus 1 cancel. So your final answer is going to be a 2x plus 1 in the numerator and x times 2x minus 1 in the denominator. For number 12, we've got x cubed minus 6x squared plus 8x over x squared minus 8x plus 16. And since we're dividing by a fraction, we have to flip and multiply. So flip the bottom fraction. This is a 10x squared minus 40x all over 2x minus 4. And we are going to factor everything that we can. First, GCF this guy. So x times x squared minus 6x plus 8. We'll factor it later. GCF of 10x squared and negative 40x would be 10x. And so you're left with x minus 4. GCF of 2x and negative 4 is 2. And let's start factoring some stuff. Two numbers that multiply to 8 but add to negative 6, x minus 2 and x minus 4. two numbers that multiply to 16 but add to negative 8 are negative 4 and negative 4. And just putting the rest of these guys down. So the x minus 2's will cancel, x minus 4's will cancel, just one of them. Oh, actually, these guys will cancel too. So 10x times x is 10x squared, and 2 is left behind. But 10 divided by 2 is 5, so your final answer is 5x squared. Alright, that's the first page. Next page, number 13. 5x minus 17 over x squared plus 5x minus 24 plus 2 over x squared plus 5x minus 24. Here's a cool thing. In the denominator, those cancel. Or not cancel, sorry. They have the same LCD, so we get to just add straight across. So 5x is 5x. Negative 17 plus 2 is negative 15. All over x squared plus 5x minus 24. So now they're combined. Now we want to factor and see if they can cancel. GCF of 5 and 15 is 5. It's 5 over x minus 3. The denominator factors. Two numbers that multiply in the negative 24 but add to 5 are x plus 8x minus 3. Those reduce. So our final answer is 5 over x plus 8. Number 14. Okay, it says solve all of this if f of x equals x plus 1. So we got 5 times x plus 1 minus 5 all over x plus 1 minus 3 times x plus 1 minus 5 all over x plus 1. In case you guys are wondering where the f of x's went, they're all right here. I just replaced every single f of x with x plus 1. Can't cancel. We have to distribute and combine first. So distribute, and remember that since there's a minus right there, you make that a plus minus. So 5x, not x squared, 5x plus 5 minus 5. Negative 3 times x is negative 3x minus 3 minus 5. All over x plus 1. Okay. Since they have common denominators, I can put them all in one numerator. And 5x minus 3x is 2x. 5 minus 5 is 0. Minus 3 is negative 3. Minus 5 is negative 8. All over x plus 1. Actually, you know what? I missed something. So plus a negative, I have to make that negative, and I have to change this sign. I forgot to change that sign when I made this positive. So in case you guys are wondering, here's what it looked like beforehand. So that's what it used to look like. So when I change this into a positive, I have to change the negative here because this is all one term, and I have to change this to a positive here. So there should be a positive 5. Negative 3 plus 5 is 2, so this would be a positive 2. So I'm going to pull something out of each of these. So pull a 2 out in front, and we get x plus 1 over x plus 1. And those x plus 1's cancel. All of that gives us just 2. Sorry about the mistake. But I found it. Heads up, how I knew I made a mistake. I had a sneaking suspicion that we were supposed to cancel something. $15. Uh, 2 over 3a plus 5 over 6a squared. So we're going to multiply on the left. So this is a 6, this is a 3. So I need to multiply top and bottom by 2. And that's an a squared. So I'm missing an a. So 2a times 2, that's a 4a plus 5 all over 2a times 3a, that would be 6a squared. 16. 5 over 8n to the third minus 7, that should be an 8. Minus 7 over 6n. So I need them to be common denominators. So here's how I find my LCD. My LCD, I'm going to take the bigger of the numbers and I'm going to list the multiples of them until I find one that can be divided by 6. So 8 cannot be divided by 6. 16 cannot be divided by 6. 24 can be divided by 6. So 24 would be my LCD. And since this is n cubed and an n, I need n cubed. Okay. So 24 divided by 8 is 3. So I'm going to multiply top and bottom by 3. 24, sorry, an n cubed divided by n cubed is 1, so it doesn't need an n. On the other side, 24 divided by 6 is 4, so multiply top and bottom by 4. And n cubed divided by n is n squared, so they both need an n squared. So 3 times 5 is 15. Negative 7 times 4n squared is negative 28n squared. All over 24n cubed. That can't be factored. $17. 5x over x minus 2 plus 10 over 2 minus x. And what we're going to do is we are going to factor out a negative 1 to make these switch. So this becomes 5x over x minus 2 plus negative 10 over x minus 2, which means 5x minus 10 over x minus 2. The GCF of 5 and 10 is a 5. So you pull out the 5 and you're left with an x minus 2 over x minus 2, and those cancel. Your final answer is x equal, not even x, just 5. Final answer is 5. It's just two brothers. Answer's 5. 18. Jonathan, that reference was for you. 18. Similar kind of situation. We have x squared over x squared minus 4 and minus 2x over 4 minus x squared. Okay. So I want to switch these around, so I factor out a negative 1. So this would be x squared over x squared minus 4. Instead of minus, this is now plus 2x over x squared minus 4. Combine them together to get x squared plus 2x over x squared minus 4. And these guys will factor. On the top, we can pull out an x over x plus 2. The bottom is difference of two squares, so that would be x plus 2, x minus 2. And reduce, x over x minus 2 is our final answer. 19. 5 over x plus 2 plus 7 over x minus 3. They need each other. So this gets multiplied by x minus 3 top and bottom. And this gets multiplied by x plus 2 top and bottom. So 5 times x is 5x. 5 times negative 3 is negative 15. 7 times x is 7x. 7 times 2 is 14. All over x minus 3, x plus 2. 5x plus 7x, that is 12x. Negative 15 plus 14, that's a negative 1. All over x plus 3, sorry, x minus 3, x plus 2. Number 20. This again. 3 over, instead of f of x, I'm going to write x plus 1. Minus 5 over, instead of f of x, I write x plus 1 plus 3. So really this problem is 3 over x plus 1 minus 5 over x plus 4. Ooh. I'm starting to lose it, guys. So x plus 4 top and bottom. We got x plus 4 times x plus 4. And then we got x plus 1, x plus 1. So distribute. 3 times 4 is 12. 3 times x is 3x. Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. All over this stuff, x plus 4, x plus 1. Combine like terms, 3x minus 2x, that's a negative 2x. 12 minus 5 is a positive 7. All over x plus 4, x plus 1. (21) for x over 2x plus 6 plus 3 over x plus 3. First things first, let's factor this guy. If we factor him, we get 4x over 2 times parentheses x plus 3 over x plus 3. Hey, it's just missing a 2. So we just have to multiply this top and bottom by 2. And we get 4x over 2 times x plus 3 plus 6. However, we can factor something out of that. We could factor out a 2. So we get 2 times x plus 3, so 2x plus 3, all over 2 times x plus 3. 2's reduce, and so this is our final answer. (22) 1 over, I'm going to start factoring these guys quickly now. This factors into x minus 2, x plus 1, plus 1 over, and this would be x plus 1, x plus 1. So on the left side, we're missing one of the x plus 1's, so you have to multiply by x plus 1 top and bottom. On the right side, we're missing x minus 2, so multiply x minus 2 top and bottom. So we get x plus 1 plus x minus 2 all over all this junk. And combine like terms, x plus x is 2x, 1 minus 2 is negative 1, all over this stuff. Final answer. 23. 2 over x minus 3 minus 3x minus 4 all over x squared minus 9. So we can factor the right side, 3x minus 4 over x plus 3, x minus 3. This is missing x plus 3, so we got to add it in, top and bottom. Well, not add, multiply it top and bottom. So these combine together. 2 times x is 2x. 2 times 3 is 6. This is a negative, so we change that to a positive and change all these signs. So minus 3x plus 4. All over x plus 3, x minus 3. Combine like terms. 2x minus 3x is negative x. 6 plus 4 is 10. All over x plus 3, x minus 3. (24). Alright, so for 24, this is the one with all the boxes. So we got 7 over x minus 4 plus 2 over x plus 3 over x cubed. And then it says equals 7 with a blank space, and then plus 2 with a blank space, and then plus 3 with a blank space, all over a big blank space. So let's talk about our LCD. Our LCD needs to consist of everything we want to eliminate in the fraction. We want to get rid of x minus 4. We want to get rid of x. But x cubed has x already as part of it, so this just turns into x cubed. That's our LCD. So figure out what's missing. In our LCD, this is x minus 4. That's x minus 4, so we don't need those anymore. So we would just write the x cubed that's missing next to the 7. Okay. So for this one, it doesn't have x minus 4. X cubed over x cubed divided by x is x squared. X minus 4. And on the right side, has the x cubed. X cubed divided by x cubed reduces, such as 3x minus 4, all over our LCD. (25). X minus 1 over x all over 1 plus 1 over x. So the LCD of both of these fractions, top and bottom, is x. So if I just multiply everything by x, top and bottom, x times x is x squared. X divided by x, those would reduce, so I get minus 1. X times 1 is x, and these x's reduce, so I get plus 1. This is difference of two squares, so this factors into x plus 1, x minus 1. And now I can reduce since I'm simplified, and my final answer is just x minus 1. 26. Four over x plus 2 over 3 over 5 over 3 plus 1 over x. And our LCD is what we want to get rid of. We want to get rid of the x and the 3, so it's 3x. So everything gets multiplied by 3x. So the x's cancel here. 3 times 4 is 12. The 3's cancel. 2 times x is 2x. The 3's cancel. 5 times x is 5x. And the x's cancel. 3 times 1 is 3. You could reduce this. This would be, not reduce, sorry. You could factor the top. 2 times x plus 6 all over 5x plus 3. Final answer. And do I have enough room for 27? I don't want to chance it. I hope I have enough time for dinner. 20 minutes, 6, okay. Alright, 27. One plus 3 over x all over 1 over 2 minus 9 over 2x squared. So our LCD, we need to get rid of the 2, and we need to get rid of the x squared. We don't got to worry about the x because that's already covered by the x squared. So everything gets multiplied by 2x squared. This times 2x squared, this times 2x squared, this times 2x squared, and this times 2x squared. So 2x squared times 1 is 2x squared. 2 and the x crosses out. 2x times 3 is 6x. The 2's reduce, and x squared times 1 is just x squared. The 2x squareds reduce, and we're left with minus 9. And let's factor top and bottom. GCF of 2x squared and 6x is a 2x, and you're left with x plus 3. This is difference of two squares, which is x plus 3, x minus 3. And you're left with 2x over x minus 3. 28. Solve for x and state if you have how many solutions you have. So we've got 6 over x minus 2 equals 5 over x minus 3. We can cross multiply. At first I thought I wasn't supposed to show you guys this, but I saw other teachers do it, so I'm just going to do it. 6 times that is 6 times x minus 3. 5 times that is 5 times x minus 2. Distribute. 6 times x is 6x. 6 times negative 3 is negative 18. 5 times x is 5x. 5 times negative 2 is negative 10. Subtract 5x from both sides, and we get x minus 18 equals negative 10. Add 18 to both sides. X equals 8. And we check to make sure it's an extraneous solution. It's not, because it's not 2 or 3. So we have one solution. One solution. Kind of like One Direction, but one solution. I'm going to start that band with the math department. We're going to call ourselves One Solution. 'Cause you're not extraneous. 29. X over x minus 4 equals 4 over x plus 4. And cross multiply. So we've got x times x plus 4 equals 4 times x minus 4. Distribute. X times x is x squared plus 4x equals 4x minus 16. And when you move everything to one side, minus 4x plus 16, we get x squared plus 16 equals 0. Subtract 16 from both sides and you get x squared equals negative 16. And when you square root both sides, you can't square root a negative, so this would be no real solution. There are imaginary solutions, but right now we're only worried about the real ones, so no real solution. 30. 2 over x minus 2 equals x over 4. Cross multiply. So x times x minus 2 equals 8. Distribute. X squared minus 2x equals 8. Subtract 8 from both sides. X squared minus 2x minus 8 is equal to 0. Factor x minus 4, x plus 2 equals 0. We get x equals 4 or negative 2. Check to make sure there's no extraneous solutions. It's a negative 2 and not a positive 2. So, you know what? Life is good. We're done. Oh, by the way, 2 solutions. Like 2 chains, 2 solutions. Never mind. 31. So we've got 2x plus 2 over 6 equals x plus 1 over 3. Cross multiply. So 6 times x plus 1 equals 3 times 2x plus 2. Distribute. 6 times x is 6x. 6 times 1 is 6. 3 times 2 is 6x. 3 times 2 is 6. Subtract 6x on both sides. Subtract 6 on both sides. You get 0 equals 0. That means infinite solutions. Doesn't matter what number you plug in, you're always going to get an answer. Did I just... Okay, I was so afraid I did that whole problem off the screen. 32. We're going to need more space. The solution is extraneous. So 9 over f of x is x plus 2, so I'm just going to plug it in. X plus 2 minus 2. Minus 12 over x plus 2 equals 3 times x plus 2 minus 6 all over x plus 2. Alright, so let's simplify some stuff. This becomes 9 over x, because 2 minus 2 is 0. Minus 12 over x plus 2 equals 3 times x is 3x. 3 times 2 is 6 minus 6. But 6 minus 6 is just 0. Cancel those out. And our LCD here, I want to get rid of x and x plus 2. So I multiply everything by x times x plus 2. And cancel out what I can. X and x reduce, so I'm left with 9 times x plus 2. And the x plus 2's reduce, so that's negative 12x. And the x plus 2's reduce, 3x times x is 3x squared. Distribute. 9 times x is 9x. 9 times 2 is 18. Minus 12x equals 3x squared. Combine like terms. Negative 3x plus 18 equals 3x squared. Move everything over to one side because we need to set this equal to 0. So add 3x to both sides. Subtract 18 from both sides. And I get 3x squared plus 3x minus 18 equals 0. But they all have a GCF. 3, 3, and 18. So you pull a 3 out, and you get x squared plus x minus 6 equals 0. And you can factor this. Two numbers that multiply to negative 6 but add to 1 are x plus 3, x minus 2 equals 0. Therefore, our answers are x equals negative 3 and 2. Go back to the original problem. Negative 3 is not an issue, and positive 2 is not an issue, so we're good. (33) 4 over x minus 3 plus 6 equals 10 over x minus 3. We want to get rid of x minus 3, so we're going to multiply everything by it. So this is multiplied by x minus 3, and this gets multiplied to x minus 3, and this gets multiplied to x minus 3. Cancel stuff. You're left with 4 plus 6 times x minus 3. And those cancel, and you get 10. Distribute. 4 plus 6x minus 18 equals 10. And 4 minus 18, that's negative 14. So 6x minus 14 equals 10. Add 14 to both sides. And 6x equals 24. And divide both sides by 6 to get x equals 4. Check, plug it back in, looks good, we don't got to worry about it. So there's one solution. The next one's 34. 34 we have 1 over x minus 1 plus 1 over x plus 2 equals 3 over x plus 2x minus 1. I factored it, you're welcome. And so I want to get rid of the x minus 1. I want to get rid of the x plus 2. This is my LCD right here. The LCD is x plus 2, x minus 1. So everything gets multiplied by the LCD. This gets x plus 2, x minus 1. This gets x plus 2, x minus 1. And this gets x plus 2, x minus 1. Cancel out x minus 1's here, so you're left with x plus 2. Cancel out the x plus 2's here, and you're left with x minus 1. And cancel both those off, and you get 3. So x plus x is 2x. 2 minus 1 is 1, equals 3. Subtract 1 on both sides, and 2x is equal to 2. Divide both sides by 2, x equals 1. So there's one solution. Let's go back. If you look at your original problem, this was an x minus 1 right here. We cannot plug 1 into that. So that does not work. There's actually no solution because 1 is extraneous. The solution is extraneous. For 35, we have x over, sorry, not that, x plus x minus 1 over x minus 3 equals 2 over x minus 3. Want to get rid of the x minus 3, so everything gets multiplied by it. So we get x times x minus 3. Those cancel, and we get plus x minus 1 equals 2. Distribute. Combine like terms. Make one side equal to 0. So x squared minus 2x minus 3 is equal to 0. And this factors to be x minus 3 times x plus 1 equals 0. So our solutions are 3 and negative 1. Look at our original problem. We cannot plug 3 into this problem because that gives us a denominator of 0. So our only solution is x equals negative 1 because 3 is extraneous. Alright. So we got 2x over x minus 1 plus x minus 5 over x squared minus 1 equals 1. First things first, let's factor the bottom. So this is 2x over x minus 1 plus x minus 5 over x plus 1 x minus 1 equals 1. And I need to multiply everything by the LCD, which is x plus 1 x minus 1. So this gets x plus 1 x minus 1. This gets x plus 1 x minus 1. And this gets x plus 1 x minus 1. So this is 2x times x plus 1. Those both cancel, so that's just plus x minus 5. And these will actually become this x squared minus 1. You would FOIL this back out. Distribute 2x squared plus 2x plus x minus 5 is equal to x squared minus 1. Subtract x squared on both sides. Add 1 to both sides. So this is x squared. 2x plus x is 3x. And negative 5 plus 1 is a negative 4. Equals 0. And this will factor into x plus 4, x minus 1 equals 0, or x equals negative 4 and positive 1. Check your original problem. You cannot plug positive 1 into this function, so therefore your answer is just x equals negative 4. Bye, Felicia. Okay. 37. 4 over x minus 6, x minus 2 equals x over x minus 2 plus 1 over x minus 6. There's a reason why I'm spacing them out. There's something that's going to go here. So our LCD is x minus 6, x minus 2. So you multiply everything on top by the LCD. So we get 4 equals, cross those out, x times x minus 6 plus, those cancel, x minus 2. X times x is x squared, x times negative 6 is negative 6x, plus x minus 2. Combine like terms. So minus 5x minus 2. And we need to get rid of the 4, so we subtract 4 on both sides. and we get 0 equals x squared minus 5x minus 6. And this factors to be 0 equals x minus 6x plus 1. So therefore, x equals 6 or negative 1. Look back at your original problem. You cannot plug 6 in right here, so therefore that is an extraneous solution. X equals negative 1 is the only thing that works. Ooh, man, I'm doing a lot of the same stuff over and over again. 38. 6 over x minus 2 minus 5 over x minus 3 is equal to 0, because this is f minus g of x. And if I multiply everything by the LCD, which is x minus 2, x minus 3, x minus 2's cancel, so that's 6 times x minus 3. Minus 5, the x minus 3's cancel, times x minus 2. And 0 times anything is just 0, so you just put 0. 6x minus 18 minus 5x plus 10 equals 0, or x minus 8 equals 0, x equals 8, and that's not extraneous. $39. For 39, a group of friends decided to get a billboard for their school. Why? And they split them up amongst X students. And it says initially there are X students, but then 9, so we have to pay $3 less. So you would put minus 3 equals x over x plus 9. Wait, sorry, no, it's 120 over x plus 9. Because they said 9 more students decided to join, so that's why you add 9 to x. We don't know how many students there were to begin with. But you're splitting the $120 up by that many people plus 9 more. So if you multiply everything by the LCD, we get 120 x times x plus 9 minus 3 times x plus 9 equals 120 x plus 9 all over this stuff. And you cancel what you can. So we have 120 x plus 1080. Negative 3x times x is negative 3x squared. And negative 3x times 9 is negative 27x equals 120x. Since there's 120x on both sides, we can cross them out and write this in standard form. So negative 3x squared minus 27x plus 1080 is equal to 0. I can factor a negative 3 out, so I'm left with x squared plus 9x minus 360. And I need to factor this, two numbers that multiply to 360 but add to 9. Huh. Let's see. I'm going to start off with 10 and 36. Because 10 times 36 is 360. That doesn't add to 9, but I mean that saves me the 1, 2, 4 step. Let's do 12 and 30. Still not right. What if we did 15 and 24? There we go. So since this is bigger, this is going to be negative 3 times x plus 24 times x minus 15 equals 0. So that means x equals negative 24 or 15, but there's no such thing as a negative person, so your answer is there were 15 students. Chet can change all tires on a truck in 10 minutes. So this is the together over alone stuff. Together over alone. So we're trying to figure out how fast they can do it together. We don't know how fast they can do it together, but Chet can do it in 10, and Destiny can do it in 15. And we want to figure out how long it takes them to do, that should be an equals, one job. So to find the LCD, we have 15 and 10. Just count by 15s. We have 15 is not divided by 10, but 30 is divided by 10. So I multiply everything by 30. 30 divided by 10 is 3, so that's 3x. 30 divided by 15 is 2, so plus 2x. 30 times 1 is 30. 3x plus 2x is 5x equals 30. Divide both sides by 5, x equals 6. It would take them 6 minutes if they did it together. And for 41, A, sketch the graph. So, man, we gotta do all this. Sketch the graph. So the graph of f, our horizontal asymptote is at negative, or is at negative 2. So there's our horizontal asymptote. Our vertical asymptote is at negative 3. And to do the graph, we go from where the vertex or the vertices intersect, that's right here. And we're going to go right one, up one, left one, up one. And let's find our intercepts first. To find the y-intercept, you plug 0 into x, so 1 over 0 plus 3 minus 2. That equals 1/3 minus 2. So that's 1/3 minus 6/3, which is negative 5/3. That's our y-intercept. So negative 5/3 would be like right here. And to find our x-intercept, you plug 0 into y and solve. So 0 equals 1 over x plus 3 minus 2. So we add 2 to both sides, and we get 2 equals 1 over x plus 3. Cross multiply. 2x plus 6 is equal to 1. Subtract 6 on both sides, and 2x is equal to negative 5. And divide both sides by 2. X is negative 5/2. That is our x-intercept. So we go to negative 1/2, 2/2, 3/2, 4/2, 5/2. And the graph looks something like this. Okay, so part D, state the domain. Zoom out for this. the domain, all numbers that you can plug in. So this would be all real numbers, but x cannot be a negative 3. For E, our range, that's all numbers except our horizontal asymptote. So y cannot equal negative 2. F, the vertical asymptote, will be x equals negative 3. G, the horizontal asymptote, is y equals negative 2. H, state the intervals where it is increasing. If you look at the entire graph, this graph is always going down, this graph is always going down, so therefore there is no increasing intervals. For part I, decreasing, it's decreasing pretty much everywhere except there's this horizontal asymptote, vertical asymptote at negative 3. So it decreases from negative infinity to negative 3 and from negative 3 to positive infinity. You have to break it up. You can't say from negative infinity to infinity because at negative 3 you don't have a graph. You got to make sure you split them up. Okay, it will always look like this with your vertical asymptote being right here. J, talk about where it's greater than 0. So it's greater than 0 on top of the x-axis all the way until you get to the x-intercept. So your x-intercept was negative 3. Sorry, your asymptote was negative 3. And your x-intercept was negative 5/2. Not a lot of time to be positive. And for K, state the intervals where the graph is less than 0. It's less than 0 all the way over here until you get to negative 3. So from negative infinity to negative 3. And it is also less than 0 after your x-intercepts. So from negative 5/2 to infinity. Vertical asymptote at 2, x equals 2. Horizontal asymptote at 1. Again, we do the right one up 1, left one up 1 because of the, oh, my bad, that's a negative 1. So it needs to be on this side actually. Negative 1 means it flips. It has to be in quadrants 2 and 4. So part B. Part B says find the y-intercept. Plug 0 into x and solve. So we get negative 1 over 0 minus 2 plus 1. So that's negative 1 over negative 2 plus 1, which is a positive 1/2. So it's 1 and 1/2, 1.5. So at 1.5, we cross the y-axis. Yeah, y-intercept. 1.5 right there. And for our x-intercept, we plug 0 into y and solve. 0 equals negative 1 over x minus 2 plus 1. Subtract 1 from both sides. Negative 1 equals negative 1 over x minus 2. And when you cross multiply, we get negative x plus 2 equals negative 1. And subtract 2 from both sides. We get negative x is negative 3, or x equals 3. So x equals 3, we cross the x-axis. And look, it's already there for us. So let's connect them. Alright, part D. State the domain of f. The domain is all real numbers, but it can't be 2. The range, all real numbers except for your vertical your horizontal asymptote at 1. I always get them. Language is hard. F. F says state the equations of the vertical asymptote. X equals 2, G, state the equation of horizontal asymptotes, y equals 1. H, state the intervals where it's increasing. It's increasing on the entire graph, except at 2. So it's from negative infinity to 2, and from 2 to infinity. Part I, state the intervals where it's decreasing. None. Where it's greater than 0, it is greater than 0 everywhere on the left side of the vertical asymptote. So from negative infinity to positive 2. And it is also greater than 0 after our x-intercepts. So from 3 to positive infinity. And for part K, it says state the intervals where it's less than 0. It's only less than 0 between our vertical asymptote and the x-intercept, so between 2 and 3. For 43, there is no horizontal asymptote, or it's at 0, and our vertical asymptote is at negative 1. But this says a negative 2, so this means we're in quadrants 2 and 4. So you're going to go left 2 up 1, and left 1 up 2, right 1 down 2, and right 2 down 1 to get your kind of starting points. Alright, so graph is sketched. Part B, find the y-intercept. It crosses the y-axis at 0, negative 2. Don't even really have to do the work. For part C, state the x-intercept. It never crosses the x-axis. None. D, state the domain. All real numbers, but x cannot be negative 1. E, state the range. All real numbers, but y is not equal to 0 anywhere. F, state any vertical asymptotes. Dang it. X equals negative 1. G, horizontal asymptotes, y equals 0. H, state the interval where it's increasing. It's increasing pretty much everywhere except for that asymptote. So negative infinity to negative 1, and from negative 1 to infinity. For I, state the intervals where it's decreasing. None. J, state the intervals where it's greater than 0. It is greater than 0 from negative infinity all the way until we get to our asymptote. Never again is it above the x-axis. So from negative infinity to negative 1. And state where it's decreasing. It's decreasing, sorry, not decreasing, it's less than 0 on the right side of the asymptote. So from negative 1 to positive infinity. (44) Find f of x. G of h of x. If f of x is g of h of x, then find f of x and state the equation. Okay, so g of h. That means you take h and you plug it into g. So this is 3 over. You don't write x. You write h of x instead. So that's just f of x. Take this part right here, and you put it where x is, where g is. Okay, plug it into x. Okay, horizontal asymptote. is y equals negative 5. And your vertical asymptote would be x equals 2. 45, same thing. Take h, plug it into g. You take h and you g it. So this is negative 2 over x plus 1, because you don't write the x, you write that instead, plus 4. Your horizontal asymptote is y equals 5. Vertical, x equals negative 1. Given this, solve it by graphing. So 8 over x. So if we plug in 2 for x, let's make a t-chart here. If you plug in 2, 8 divided by 2 is 4. So 2, 1, 2, 3, 4. And if you plug in 4, you get 2, because 8 divided by 4 is 2. If you plug in negative 2, you get negative 4. Plug in negative 4, you get negative 2. So the graph looks something like this. And it says g of x equals 4, so let's do g of x in red. And since it's just equals 4, that means it is a horizontal line. And they cross right there at x equals 2. So therefore, your solution is x equals 2. Solve it graphically. 8 over x equals 4. Cross multiply. 8 times 1 is 8. 4 times x is 4x. Divide 4 on both sides, and x equals 2. And how are the intersection points on the graph related to the algebraic solutions? They are the same. Peace.